Assistant Professor, Department of Physics. Today I am going to explain this experiment. The experiment name is Poisson flow method. We are going to determine the viscosity of the given liquid by using Poisson flow method. Yes, already I have studied about the Poisson flow method in the first unit itself. Viscosity of the given liquid. The given liquid is nothing but water. See the apparatus details. We will be having burette stand here. Burette is fixed inside the burette stand, and this is capillary tube. Beside this, we will be having two beakers and one stopcock. These are all the apparatus we are going to use in this experiment. Now, I am going to start the experiment. See, burette is fixed inside the burette stand. I am going to fill this burette by using water. We have to fill the liquid above 0 cc level. We will be having markings in the burette. We have to fill the liquid above 0 cc level. Now, I am going to open this knob slightly. See, if you open this knob, the water will flow inside the capillary tube and it will reach the beaker. I think you can see the drops which is coming from the capillary tube. Now, take this stopcock. Once, see now the water liquid is above 0 cc level. Once the liquid level reaches the 0 level, we should switch on the stopcock. And it decreasing. For every 5 cc decrease in water level, we should note the readings from the stopcock. The liquid crosses 5 cc, 10 cc, 15 cc and it goes on. For every 5 cc decrease in liquid level, we should note the time taken for that decrease in water level. We should note up to 40 cc or we can take up to 50 cc. For every 5 cc decrease in water level, we should note the time. Now, see in this tabular column, the first column will be water level in the burette. So, we can take it as 0, 5 cc, 10 cc, 15 cc, it goes on up to 50 cc. That is the water level in the burette, markings in the burette. Second column will be time. So, for every 5 cc liquid in the decrease in the liquid, we should note the time taken here. So, for 0 cc, what is the time? And for 5 cc, what is the time? And for 10 cc, what is the time? We should note the time continuously without switch off the stopcock. And the third column will be range. Range we can take it as 0 to 5, 5 to 10, 10 to 15, 15 to 20 and it goes on. So, for a range 0 to 5, the initial reading or initial value will be 0 and the final value will be 5. Yes, that is the third column. And the fourth column, time for flow of 5 cc liquid. So, for every 5 cc liquid, what is the time taken? So, we should subtract the second reading from the first reading, third reading from the second reading and it goes on. So, time for flow of liquid for every 5 cc level. And the fifth column will be height of initial level. So, already we took the range as 0 to 5 cc. So, initial level is 0 and final level is 5. So, now height of initial level is from 0 cc to table. What is the height? That is the value of H1. Height of initial level from 0 cc to table. What is the height value? So, by using this long size scale, we can able to measure the height from 0 cc to table. That is the value of H1. So, in the range, the final level will be 5 cc. So, from 5 cc to table, what is the height? That is the value of H2. Now, yes, H1 value, H2 value, we already taken. Yes. Now, the next column will be pressure head. The formula is H2 is equal to H1 plus H2 divided by 2 minus H0. H0 is the distance between or height of the capillary tube to the table. Yes, the distance between the height from the table to the capillary tube is H0. Now, we have the values, three values H1, H2 and H0. By substituting all the three values, we can able to find the value of H. The formula is H1 plus H2 divided by 2 minus H0. So, we can able to find the value of H. The final column will be H into T. Yes, we know the time T value already it is there in the fourth column. if we multiply the time t and the height h, so that we can able to find the Ht values. So finally we should take the mean value for all the Ht values we found. Now what is the formula for viscosity of liquid? Eta is equal to pi rho g a power 4 Ht divided by 8 Lv. Now rho is the density of the given liquid, that is for water the rho value will be 1000, and g is the acceleration due to gravity, its value is 9.8. A is the radius of the capillary tube. So we should find the radius of this capillary tube by using travelling microscope, that is the value of A, radius of this capillary tube. H is the mean pressure head, H into T, its value is already there in the table, so we can take the value directly. Divided by 8 Lv, L is nothing but length of this capillary tube, so by using the scale we can able to measure the length of this capillary tube, and finally V is the volume of the liquid. So volume of the liquid is nothing but 5 cc, so 5 into 10 power minus 6 meter cube. So if we substitute all the values in this formula, we can able to find the coefficient of viscosity of the given liquid, that is viscosity of water. Thank you.